is there any valid methods to measure heterogeneity for meta-analysis of rare events? As we know, generic methods tend to underestimate the heterogeneity for rare events. Julian, did you want to comment on that, maybe?
Well, it's not a very easy one. I guess one of the approaches I quite like for rare events, I guess, is moving to a generalized linear mixed model, or just a generalized linear model framework. Well, no, it has to be mixed if you're doing random. And within that's among the stronger methods, because you can explicitly model a rare binomial probability. And through that, especially if you put it in a Bayesian context with a suitable prior, you can begin to learn about heterogeneity. But there's much, of course, less information about heterogeneity when you've got very few events. So it's inherently difficult. So I found one or two for each speaker that we could run through. Do you want to do that? Carla. There was a question about modeling. I noticed that you included this random effect for the study baselines. And I was kind of wondering why you did that. It didn't seem necessary for your I-squared analog. But there was a specific question in the chat about why we don't model the treatment effect as random rather than the interaction between study and treatment as random. I wonder whether you might reflect on, very briefly, it's a really big area, I know, very briefly on this choice of random effects.
Yeah, so it is important to think about how you might model those different random effects. And there are different choices, not just the choice that I made in my primary sort of comparison. I chose this route because I come from modeling data in cluster trials. And in a cluster trial, we would generally have a random effect for our clusters that allows our clusters to differ, but not necessarily always have a random effect on the treatment effect across the clusters. So that's why I started from the approach that I took. And it is important, if you've got two random effects, one for the study and one for how the studies react to the treatment, it is very important to have that covariance term there. And if you don't have that covariance term, you end up making assumptions that are not immediately obvious. The alternative is to put a fixed effect on the study estimates and allow the studies to then have a random effect in how their response to the treatment. That's an alternative, perhaps more intuitive with the way that you typically analyze meta-analysis data. And I did have that in a few of my plots, and it doesn't really make very much difference.
Okay, thanks. There was an interesting question in response to you, Ralph. You were comparing different shapes of prior distribution, and someone asked whether, for example, in a half normal situation, we could elicit the parameters rather than looking at data. I wonder, you any thoughts, Ralph?
I need some explanation what you mean with eliciting priors.
Elicitation is the old-fashioned way of doing it for lots of Bayesians, where you sit down with an expert and ask them what they think the parameters of the distribution should be.
Okay, this approach we also do, because the plan is to discuss it with experts from biometric societies. Maybe you can see this as input of experts, that what we see in our data is the thing which will be accepted by the biometric community. Then we will have a good feeling.
Indeed, and I've forgotten who asked the question, but it reminded me that the very first paper on Bayesian meta-analysis that I was aware of, from David Spiegelalter and Teresa Smith, they describe prior distributions by introspection, is the word they used in particular chapter. And they actually talk about it in their Stats in Medicine paper from '95, about saying, well, what would be a ratio of big to small treatment effects, and translating that into an inverse gamma effect prior for the heterogeneity variance. Should we take a question for Selena? Can I give you one very quick question and a slightly longer one? The quick answer, hopefully, could you just clarify what scale you were measuring prevalence on, Was it the logic transformation or the raw prevalence? Someone asked. But the more meaty question is it, would you strongly encourage, as a matter of course, doing meta regressions of prevalences, as Ian suggested in his summary?
Okay, so we actually, the sample of meta-analysis were from published systematic reviews, and we assessed the I-square and the results in whichever scale, using whichever transformation method the reviewers have chosen. Interestingly, more than 70% of reviewers did not report which method they used, but among the ones that reported, the most used were Freeman, Tuckett, double arcsign, and logit. And regarding the second question about the meta-regression, when I brought to you the information about sensitivity analysis, this included meta-regression. So in some cases, it was conducted, but I would say that the rationale is the same. You should conduct a meta-regression if you have a factor of interest and a high heterogeneity level, a substantial variability in the estimates, and you want to explore which variables could be associated with this, not just because you found a high I-square level.
Thanks. Arji, have you been looking at the recent questions, which I have asked?
Quite a few, I would say. So one comment says from Wolfgang Bichbauer, thanks everybody for your interesting presentations at Ralph. Even if two studies are significant, a random effects model is trying to make an inference about an entire population of studies. With two observations from that population, it is no surprise, in my opinion, that the CI for the average effect in the population of studies is so wide. It should be. Also, the confidence interval from the Knapp-Hartung method has approximately nominal coverage, even if the number of studies is equal to. So in what sense is the Knapp-Hartung too conservative? The question.
Yes, in our view, if the confidence level of a pooled effect estimate contains all the single confidence intervals of the single studies, then you have no new information from this pooling. And then it's not informative, and probably we should use a different approach. And the situation, you have two significant studies, but the pooled effect estimate is clearly not significant. You have no valuable information, and you have a large break. I explained it shortly in the talk. If you have only one study and this is significant, then most people will think there is something. Okay, it's better you have replication. And if you have this replication and the second study, then you say there is no effect at all. This makes no sense. No.
And there's a couple of questions in the chat about using use of I-squared. One is thinking if it's only suitable for trials. I don't think it's only suitable for trials at all. I think all I was saying is those thresholds were created based on trial data. That's all I was saying. I wasn't trying to say that I-squared shouldn't be used elsewhere. I think it's potentially got uses if interpreted correctly. So and someone asking a similar question, so we can't use it for prevalences, what should we use for prevalences? I think that is an interesting question, and Celine, maybe you'd like to reflect on that, because I always see prevalence I-squareds in the 90s, and so I would just expect it. It's not a problem if you deal with it appropriately. But what would you say, Selina, to that one?
Yeah, so currently I think the best option is prediction intervals. So it's a way to explore the variability and the distribution of estimates in a way that it speaks directly about what we want to know. If we can expect a wide or a narrow variation of prevalence under different contexts being evaluated. I don't say that I-squared should not be used in prevalence meta-analysis. That's definitely not my point, but it should be interpreted with caution and using it in the right way, in the way it was meant to be used, and being careful to assume that a high level of I-squared is synonymous with a high level of heterogeneity, because that might not always be the case.
Indeed. Of course, prediction intervals need to be interpreted with a great deal of caution as well. I mean, if we think that this Hartung interval around 2 studies was really wide, if you put prediction intervals on these sorts of things, they look completely ridiculous. So with small numbers of studies, prediction intervals are really very potentially misleading. So I think we need to put caveats around everything we do, sadly. I don't know, Archie, if you picked anything. There were some questions I found interesting a little bit earlier on around the difference between subgroup analyses and meta-regression to understand heterogeneity. And again, we could talk at great length about that. I don't know whether Ian, we haven't asked you to speak for a while. Would you like to say something about the potential strengths, if any, of meta-regression over subgrouping studies?
Well, I think the pitfall is people go back to the significance testing paradigm, and they say that there's heterogeneity if it's significant. And then as soon as you go down to subgroups, it's very easy to make it not significant, and so you claim you've explained it. So that's why, yeah, I mean, that's why I thought that meta-regression, just saying, is there a difference between these subgroups that's more than is explainable by heterogeneity, has got to be the right way to proceed. But you obviously want to put that alongside a subgroup analysis.